Okay. Welcome to everyone. Good morning, good afternoon, good evening, depending on where are you right now. Thank you, first of all, to everyone who joined yesterday to the first series of the conference Building for the Real World. It was a pleasure to see how this initiative has been taken really well by all you, and to see how many people was looking at the conference, at the amazing conference of Mariana and Jessica from Comunal Taller. Also, I want to thank you, the Cooperational Center of the Polytechnical University of Barcelona, for sponsoring this activity and for providing us with the funding to organize it. And I also want to thank you, everyone who is watching us today for the second series of the conference. So my name is Laia. I'm also part of Un Refugio Colectivo, which is a collective group of architects and researchers working on development projects across different countries, and also organizing academic activities in different universities since 2018 to promote a more responsible architecture among architectural students. So today's topic of the Building for the Real World Conference, Series 2, is architecture, resources and building materials. And for so, it couldn't be we couldn't have a better speaker in today's conference. So because we have Cooman, which is a co-founder and partner of BC Architect, who was founded in 2012, and BC Materials, who was founded in 2018. He's an architect, graduated from the St. Lucas University in Brussels, and he will be talking to us about the work of BC Materials. So to briefly tell you why we think that BC Architects is a perfect example for what we want to discuss today, I have taken a exactly description of a text they had about the description, which is BC believes that in order to have a positive impact on our society, architects must intervene beyond the narrow definition of the professional who designs and controls the execution of buildings. And that's why exactly we decide as well the title of our conference, because we think that the profession of architecture should move beyond the mere fact of building, of constructing, taking care of other processes that are happening behind, as for instance, the use of building materials and the responsible use of the techniques that are implied in the construction. So Ken will shortly present the work they do, but as many of you already know, they are a pioneer company and a cooperative working in researching and innovating with building materials, specifically with earth and materials. And currently they are working on producing as an industrial way materials that are sustainable and responsible for the construction sector of in Europe. So I don't want to enlarge this so much, so I'm gonna give the floor to Ken, but before I will remind you that you can make questions from the YouTube live streaming, and I will be collecting the questions, and at the end of the conference, of the speech, we will be answering the questions in the QA session. So if it's okay, I give the floor to you, Ken. So thank you very much also to you for accepting this invitation and for being here with us. It is a real pleasure for us. So it is yours.
Thank you. Thanks for having us as BC, coming and talk a little bit about our activities. I will maybe start sharing my screen. Tonight I will talk a bit about how BC Architects came to be and how it evolved in the end until much more than just an architectural office. I hope that now will be possible for you all to see the screen. I guess that should be possible now. If not, I will hear it in the chat. So tonight, I'm telling you a little bit about these organizations that BC is acting through. There's three legal entities that at this moment have seen the light, so to speak. There's BC Architects, an architectural office. There's BC Studies, which is a non-profit organization that also does research and experimentation. And there's BC Materials, which is a material production cooperative. So it already shows in the fact that there are three legal entities that we need in order to do our activities. It already shows a little bit what our approach is in the field of architecture and construction. And in fact, for us, we worked a little bit on the occasion of the exhibition of the Biennale of Venice in 2018. We worked a little bit on it for us as to what it exactly was, what we were doing, or what that we wanted to achieve in this book, which is called The Act of Building. And in fact, the act of building, as a concept, as a title for us, kind of already pointed to our activities, because the act of building is at the same time taking action. It's like acting upon something. It's doing stuff with your hands. Maybe it goes a little bit towards activism, which is also taking action in a certain way. But the act of building is also about a theater play, a kind of a performance, a kind of story that we are telling that we hope has impact in the minds of people. So it's also a cultural activity in a way. It's about a reflection of how are we humans intervening in the world? How are we building our infrastructure, our buildings? How are we living together, and so on? That's also a part of the act of building. And so, in fact, then these three legal entities that we need in order to do all of our activities in architecture and construction, producing materials, building things, designing things, researching, writing, educating, and so on. In fact, these three legal entities, of course, they reflect or they channel activities from one collective, which is BC. And it's one group of people working on different things that we need to split up in order to be active in our society. Like the ideas are one, but the activities need to be split up mainly for legal reasons. So I want to start today by explaining our first project when we were actually still students or graduating or just graduated. It kind of skipped a little bit from the studies into the professional life. It's the library of Muyinga in Burundi. So in fact, this was a very small project. The budget, as you can see, was around 20,000 euros for 140 square meters. It was auto-initiated and self-funded, let's say. We crowdfunded, in a way, this building. We made it together with a lot of partners in Burundi and Belgium and so on. And in fact, it was the pilot project, the first building for a school of deaf children. So the first building was to be a library that would also at the same time serve as a library for the school, but also as a library for Muyinga. And so, yeah, this is the context that we worked in. We see here the orange dot, Muyinga, which is not the biggest or second biggest, but maybe like fifth biggest town in Burundi, bordering to Tanzania on the right and Rwanda in the north. And I want to show this picture directly because it already shows the context in which we're working. This is the building materials shop in Muyinga. It's the only building materials shop. So if this shop didn't have it or couldn't order it, we couldn't build with it. So of course the shop was in touch with Bujumbura and could order concrete blocks or even import things from Tanzania that come maybe from China and so on. So this little building materials shop was very connected to a kind of more global economy. But at the other hand, the budget did not allow for us to use these imported materials. We had 20,000 euros for 140, 150 square meters. And so we immediately embarked, still being architecture students or just graduated, not having any experience in architecture or construction, kind of out of an economic necessity. And also from an ecological perspective, but maybe more because we were really forced to. We kind of went very extreme in only using local materials. In the end, it turned out that most of the materials were coming from less than 5 kilometers from the construction site. And just to quickly show what these materials were, we worked for this project with nature stone that we see here a little bit down the side, like a few hundred meters down the road. There was a nature stone that was being quarried from the hills. Burundi, just like Rwanda, is the country of 1,000 hills. So really amazing resources in terms of nature stone from the mountains, clay from the valley, and so on. Here we see the clay from the valley, a local roof firing workshop or factory maybe. This was a valley clay, so alluvial clay, which was gathered around the rivers in between the mountains, of which the color, as you see, is a little bit grayish and becomes pink or salmon after it's fired. Very strong clays. Here we have the eucalyptus trees, which are being cut into planks. This was another material that we used a lot in the project. And also the sisal plant, which was from the site, as well as the eucalyptus trees, of course, on the site. So we had to clear the site to make way for the buildings. And so the eucalyptus was used in the project, and the sisal plants was also used in the project. We will see a little bit later in what way. We went further in our research about what are the other local materials that were available. And so for the bulk of the materials of the project, namely the walls, we were looking for a good option. And so here we see the baked bricks with the same clay as we saw with the roof tiles, but in another valley. And we see a field oven here. So they fire a fire inside the field oven and bake the bricks in this way. But immediately, it's very clear, super obvious that it leads. This quantity of firing leads to a lot of issues on the hills. We see like a deforestation happening here on the hills, and so even though this was a local material, we kind of felt that it was not really the way to go on the long term. You know, this was a material that was considered to be for the communal projects that have more budget, or for the people who can afford to build a villa somewhere and durable, like strong materials. But for us, it already seemed like the way of firing, the inefficiency of the kiln and so on, what it did to the environment raised really a lot of questions for us as young architects being in Burundi for some time. And so we looked further, and walking around in Muyinga, we had like this backside of little houses that were built. It's not a very dense town, so, and in the backyard of those little houses were activities such as this, which was another type of block making, but in fact raw earth blocks. So adobes, sun-dried blocks were made here. This was the kind of small quarry of laterite earth that was being excavated, a very red color because of the iron content bound to the clay particles. And in fact, this made for these very strong blocks that we saw here. These are these houses. And so we see here that we are looking to the construction materials that are actually for a different kind of type of infrastructure or houses, let's say. This was more the houses of the low income people of Muyinga, the bulk, the 99%, let's say, of Muyinga. Where we were in fact really amazed by the strength of these blocks. So you see here, these houses are just put on the ground. You see a little bit of capillary water, but these houses stay there for years and years and years, even with, let's say, not proper detailing, how we would detail foundations in terms to control the capillary rise of water, how the rain was just like, hitting these walls from the top also here. And so these are not optimally built houses, and still these adobe blocks were so strong after years and years and years. And so we were very amazed by this. This was our first contact with earth construction for us, and this trip and this stay in Muyinga. And so we were very surprised and amazed by the strength of this earth block, just earth and so strong. And so we looked a little bit further into it to see if this would be a viable material for our project. And so when we were excavating, leveling the terrain, we were a little bit building into a mountain. So we had to excavate. You see the mountains of earth, like small heaps of earth in the back. And so we were researching, what can we do with this earth? We're going through all the terrain tests that we could find on the internet. You have to imagine, we just graduated, never constructed before, didn't know anything about earth construction. So we really dived into all the documents that we could find on the internet, all the books that we could lay our hands on, all the people that we could speak to in our small network that we had in the time. And we really went into testing the earth of the site and trying to grasp what we can do with it. It was a big work because we did not have any experience. And in the end, we chose for a compressed earth block, as you see here on the columns here, or here being laid. This compressed earth block was chosen for because, in fact, the adobes that we saw before would have been very fine to use for this project also, but in fact, culturally, adobe blocks were not acceptable for the local partner, neither for the local community, because it's not the material that you use to build a communal infrastructure in terms of pride, because people are more proud of what they do together, what their communal infrastructure is, than possibly their own homes. So to use the adobe blocks for communal infrastructure was just a straight no. So what we did was we made these compressed earth blocks, as we will see a little bit later in the movie, with this earth that was excavated from the site. And here on this picture, I like to focus a bit on this picture because it really shows how we worked. So in fact, centrally in this picture, as you can see, is Salvatore. This is the foreman. This is the guy who was running the construction site. And as he is central to this picture, he was totally central to this project. And we see here, for example, Nicolas on the side of the picture. Nicolas from BC. So he is, we were kind of learning a lot ourselves. We were actually not totally in the center of this project. We didn't know how to construct. We have never built before, let alone draw details for the real world. We came from a university that was very strong in storytelling, but not in detailing or in construction. And so we were very lucky to have Salvatore, who guided us, who designed with us, who detailed together with us, who knew his local climate, who knew his local materials, and who really made this project work. And without Salvatore, it would have been a disaster. So Salvatore, he's a foreman. I would say it's a little bit a position of a master builder. He did not have a company of a contractor. He did not have a degree of an architect, but he built, for example, the Basilique of Muyinga, which is a really beautiful kind of big building with vaults and everything. And so he has this position in between a designer, because he designed the Basilique of Muyinga also, and a builder. He runs the construction site. He knows what to do. He knows how to make the mortar. He knows everything about construction. He's around, at that time, he was around 60, 65 years old, still going strong, really a very respectable person. So then we have here, for example, a student from Belgium who was joining us. We have here a student engineering from Bujumbura who was joining us. And we have here the workers from the community of Muyinga who were working on the project. So just to show that the team, it's not about only BC. This is the team that did the project in Muyinga, and without anybody of these people, it would not have been possible. I will show a picture, a video, because it tells more than an image. Let me try like this. So this is Salvatore. We're clearing the site here. Salvatore does it with 60 workers for 1 month of work, instead of renting a bulldozer for 1 week, let's say. And it's like to provide the income for the community of Muyinga. And so we're clearing the site here, digging out the earth that we put aside in order to make the blocks later. Here the earth is being put aside. It's being sieved into 0.5 millimeters so that we have the biggest stones out of it. It's being mixed together with an earth from 100 meters further to make it a bit more sandy. And it goes to these 2 yellow machines, which are called the Terstaram machines, which we luckily found totally forgotten in the ateliers of the local partner, which was the Diocèse de Muyinga, the Bishopry of Muyinga. And so these Testarams are like a hand press of compressed air blocks, where the blocks come out like this, humid, and they have to be carefully being put on this carrier device, where from there they go to the storage where they dry for a few weeks. So this is a kind of setting up a production chain in a way, like you dig out, you put aside, you sieve, mix, humidify, press, transport, dry, transport again, and then you bring them to the construction site where they are being masoned. And so instead of having concrete hollow blocks as a construction, or big bricks as a wall construction, here we have compressed air blocks with a ring beam on top of it. And here we see the eucalyptus trees of the site, and that we cut to clear, to make way for the buildings. We see the eucalyptus trees being cut into beams that serve as the roof span. And here we see the sisal plant that I was talking about before. We take the fibers from the sisal plant. We use the fibers in the mortar between the compressed air blocks, but also to make a net, as we see here. We make like a big hammock. Which is the fisherman who makes fishing nets, who comes and explains his technique to the workers. And then in the end, we come up with this big hammock that is used for the kids to, relax and chill and read on top of the library, kind of a mezzanine structure, a kids-only space for reading. Here we see the whole team. Lawrence is a little bit too late for the picture, but anyways, yeah. So you see, it's a big project. A lot of people who worked on it, and in fact. I always say that like without Salvatore, the foreman and the master builder, this would not have worked. And in fact, like even this project, even if we just graduated from our masters in architecture, we always say that this project, we lived there for around 8 months, non-stop, continuously. Some people went earlier, some people arrived, and so on. But like 8 months, we were there, living together, building together with the people there. And so we always say that this 8 months was our second masters in a way. Like Salvatore and the context taught us so much, and it was so defining for everything that we did afterwards, that this education in a way for us was as important as our 5 years of architecture studying at St. Lucas University. And we just hope that that the community of Moinga will at least have gotten as much of the building and the infrastructure and the process than we have gotten from Moinga. So here we see the building. You see the red color, the salmon color, the wood color that blends in its environment. It's made from local materials, and one way or another, you just feel it, that it's part of its environment. Here we see on the inside, it's good to show the finishing materials. So we see the eucalyptus trees being transformed into furniture also into beams and rafters, I think, rafts, I don't know. We see the local valley clay being fired into roof tiles and floor tiles. We see the local valley clay being unfired, being used for clay plaster. And we see the red earth from the side being used, that was excavated, being used for these compressed air blocks all over the place. And we see the sisal plant from the side also being turned into fibers that are turned into a big hammock. Also fibers into the mortar and into the clay plaster that we see here. So there's not a lot of imported materials. We have a bit of steel for the windows. We have the ring beam in concrete. We have the lamps and the cables. But for the rest, I mean, the big bulk of the materials are really coming from local materials. There's also like considerations that we try to take into account in terms of bioclimatic design, and like cross ventilation. At that time we didn't know so much about the hygrothermic properties of Earth, but the effect on the interior climate was really amazing. Like in warm temperatures in the hot season of Burundi, on the inside we were reaching 21, 22 degrees, which for the kids was cold. In fact, like they were saying it was cold. But anyways, like a very good building in terms of passive climatization, based on how we try to orient the space and the overhang and the cross ventilation and so on. Then after this pilot project, we continued every summer with new funds for extra buildings in order to continue to make the school for deaf children. So this is the sanitary part, which has been added together with the playgrounds. Then we see here classrooms being added. And in fact, every summer we were a bit less involved. It was more and more Salvatore with his team who was doing the works. And now we have here, we don't even have the picture, we have here another classroom and administration. And so at this point, the half of the school is built, let's say, but it's functional. There should have been a dormitory, but around 7 years ago, the political turmoil was a bit happening in Burundi. So the summer of construction was cancelled, was not possible. And then from there was few years difficult. And so now then the funds changed and so on. So anyways, at this moment, we have a small school of deaf children, which is operational, but without dormitory. That's a bit, it's a bit a pity, but at the same time, it's really nice to be able to have done to have started up the school for deaf children, because it was it's very necessary to provide this education for these kids. So yeah, this was our first project. You have to imagine, like, never having built before. When people would ask us what is architecture or how do you construct, we could only talk about the stuff that we did in Burundi. It's the only experience that we had. And so we had other projects from there in Morocco, in Ethiopia, in Nigeria, and so on. And so when we came back to Belgium, in a way, we did not really know, aside from hearing from friends and so on, we did not really know the ways of construction here in Belgium, let's say. And in fact, we kind of discovered something that we really believed in, and by being allowed to construct in these different countries in Africa. And so we wanted to take that vision also back. So on the one hand, we didn't know how to do it the Belgian way, and on the other hand, we didn't really totally want to do it the Belgian way. And so the first project where we felt that we could really valorize this way of building, this act of building that we have learned in African countries, was for us the project for the bioclass in Fort 5. It's a park in south of Antwerp. And so this was a class for education around ecology and biology for kids of the Antwerp region. So all the schools come to this classroom, this kind of external classroom, where they come and learn for 1 or 2 days, and so on. So it's a little center that receives a lot of schools. And so here we see the park, which was an old fortress in the south of Antwerp, where we have the military warehouses still built a little bit later. Here, and inside those military warehouses was in fact a project. Here we see the fortress, like masonry architecture, all built on compression, all designed on compression, where you have nice vaults where baked bricks span the opening. So if we were looking here at local materials, the history of the region was a history of baked bricks and clay, a lot of high quality clay from the river Rippel. It's a kind of a valley, but with much less topography, where sediments of clay have accumulated over the past millions of years. It's called the Ypresian clay or the Boomse clay. We're here in Boom, which is around, I think, 1 or 2 kilometers from the site. And today it looks like this. So today it's a big quarry commercialized by Wienerberger, the big multinational. And so, yeah, the most local material that we could find around the project was this quarry. So it's earth that we used from this for this project. And in fact, it's a telling anecdote to know that when we were asking if we could buy some earth from the quarry, that Wienerberger could not find a way to sell us the earth, because in their invoicing system, the earth did not have a value, and they could not allocate value to earth which was not yet processed or fired. So I think that shows a little bit as an anecdote about how raw earth is considered in our construction sector in Belgium. It's not being considered as a building material, as something that has value. It has only value when you bake it at 1100, 1300 degrees, when it becomes a baked brick, and then you can sell it for a certain amount. So we were inspired by the compression design, let's say, of the walls on the site, and this military fortress where everything is built with arcs. And so we designed this very simple module with compressed earth blocks also. We repeated this module 6 times, 1, 2, 3, 4, 5, 6, as a load-bearing structure, very minimal, one-story building. And we kind of put a blanket of insulation on top of that load-bearing structure. So the insulation is hempcrete, and the structure is compressed earth blocks. It's a very simple building. What you see is what you get. You see the structure as a finishing, and you see the insulation as a finishing. So this earth that we were using for compressed air blocks was too clayey, so we needed to work with different kinds of sands, maybe another type of earth also, to find the right mix to make compressed air blocks. And we did that in a prototyping workshop that was done first between ourselves and some people around us, but secondly also with a lot of people from the neighborhood, architects, like the structural engineer of the project. Here we see the structural engineer of the project masoning, because he didn't really trust earth blocks. This was the first public earth block building in the Benelux. So you have to imagine, you know, like how afraid people are to do this. Will it hold, and so on. This is the mason who, for the first time, works with compressed air blocks also. So everybody needs to be introduced to the material. Everybody needs to, you know, come on board with what we together want to achieve. And so that takes a lot of investment, also a lot of design of the process. And so, yeah, maybe here it comes back a little bit, the act of building. It's not only the act of constructing and like putting one block on top of the other. It's also the act organizing the process, the cultural aspect of it, the impact on the minds of people, where we really need to talk a lot about what we're doing and why we're doing it in order to make people really do it. Because otherwise people will just continue with doing the works that they know, which is concrete and so on. So the act of building here, like the design of the process to make another type of building happen. Yeah, this is the arc that we made, the mason here finishing the arc, being convinced about it, and so on. And so when we were going to really the project, how we needed to build the project, there was, of course, there was no contractor who wanted to make the compressed air blocks. There was no contractor who could do the hempcrete in this specific layout and quantity as we wanted in a public project. So we had to organize workshops in order to make it possible to build with these materials. And so we made a hempcrete workshop of 2 weeks and a compressed air blocks workshop of 3 weeks. And I will show the movie to show a little bit how that went. And again, it was really, really a total design of this process of execution to make it happen. We could not do it in the standard way of asking a contractor an offer and comparing offers and then saying, okay, you get a project and then let's go for it. No, there was this whole aspect of sensibilization, of education, of everybody involved in the project in order to make it happen. And here we see already a glimpse. So this is the earth when it arrived. We dried it like, spread it open like a potato field. When it's dry, put everything on one heap, and yeah, installing the machines to start the production. The first action was in fact crushing these dry clay blocks, the clay that we dried. Then mixing the clay together with different types of sand to have this mixture with the right humidity. And then it goes to the machine, this time a hydraulic compressed air machine, semi-automatic, where the blocks are being compressed with 15 tons instead of 3 tons with a hand press in Burundi. And so yeah, you see here 19,000 blocks being made, and this was made in 3 weeks. Here we see the workshop happening. This is team 1, team 2, team 3. Each team was doing 1 week, and so we were eating together, having lectures together around earth construction and so on. So this setting of a workshop of education and construction was very, like a very nice time to do, and really informative for everyone involved, and the only way how we could construct a building. Here we see the mason doing its thing. This was not a workshop, just a mason doing the masonry, preparing everything for the second workshop. And the second workshop was the hempcrete workshop, where we worked with in 2 weeks with around, let's say, I think around 60 people, but in rotation. We had around 10 people per day for 2-3 days. And so we're mixing hemp fibers, hemp shifts, in fact, hemp shifts with different types of lime, and then compressing it in a light formwork, because the compression is not so strong as dirt, for example. A light formwork, layer per layer, and then in the end also even the roof. And so again, this is like innovative. This is the finishing of the insulation. On the inside, we see the hempcrete also as a finishing of the ceiling, and it's really first time that hempcrete is being used in this way as a finishing, also as a ceiling finishing. It's a workshop, so sometimes things go wrong. For example, the first time when you take the formwork away from the hempcrete ceiling, the hempcrete came loose because we were too fast of taking the formwork away, and the hydraulic line did not set enough yet. So this is all part of the learning process, where we're all in it together. It's a workshop. We're all learning. There's not really the expert who knows how to do it. It's like a joint undertaking to make things work. And so in the end, the nice pictures, just like in Burundi also, and after the process, the nice pictures that go around on the internet and are being published and so on. But I hope that I made clear through the lecture that in fact it's the process, the design of the process, which is at least as important as the end result, because only by rethinking how we do things can we achieve new things, new ways of building that are more adequate for our challenges that our society has today. And that's something that we continue to do at BC. We try out new processes, new ways in order to have a different kind of impact on our construction sector. Here we see the compressed air blocks. And so from these experiences, first in the countries, some countries of Africa, then to Belgium, a little bit in France and so on, we kind of build up this vision of, hey, like maybe in order to have more impact in the construction sector, maybe in order to spread the word more about what needs to be done in our sector in order to bring change, to bring transition, maybe we need to also start working in a different way. And that was with the creation of BC Materials, which is in fact a company that came into existence into the end of 2018, where in fact we wanted to really go deeper into this chain of production of using earth from construction sites, our urban quarries, let's say, to use earth from construction sites and in order to make them into building materials for other architectural offices, other contractors, other clients, and so on. So BC Materials came to light, a material production cooperative, where we kind of tapped into this waste stream that we discovered. Like if we were researching, like, hey, what we did in Burundi, like excavating from the site, in Belgium it happens also. Like how much are we excavating? And so it seems that in Belgium we're excavating from construction sites around 37 million tons per year, or around 1.2 million trucks of transport per year. So this is a little bit the road that it follows. So you extract it at the construction site, it's being transported to a temporary storage place, and it's being transported to some kind of landfill. And sometimes the extraction on the site leads to a usage of the material on the site also. So we kind of intervene on this supply chain, and we say, hey, this 37 million tons which is being excavated every year, we don't have to throw it away. We can make building materials from it. We can do this on the site itself with our mobile machinery, or we can do it with a transport to our production place, where in Brussels, where we can have a stock production. So we can work project-based on site, or we can have a stock production in our production hall here in Brussels. And so, yeah, our story as a production materials company is in fact, hey, we're here, we're tapping into circular economy in two ways. We are using a waste stream, so we're circular in origin, but we are also making materials which are endlessly reusable in the future. So we are circular in destiny. We are totally low carbon production. We don't deplete resources because we use resources that are excavated anyways. So this is, this is a new kind of business model. So, let's use it in your projects. That's a bit our selling point. So of course, earth construction is healthy, bio-based, and has texture. For us, it's beautiful. I will maybe not go too much in detail here about acoustics and about non-VOC and so on, but I think most of you will know it already. And so when we look at our quarry, let's say, most of our resources we get from Brussels. So this is a section, geological section of Brussels. Here we have the low canal zone, let's say, and here we have the high, what we call high Brussels, where we have different types of geological layers. So these yellow and orange layers that you see here are in fact sand. Historically, there were quarries in Brussels that was providing mortar sand, so sand to make mortar, to mason. Now it's totally fully built, so these quarries are not existing anymore. But of course, there's small quarries happening, namely if there's a project here with an underground parking garage, for example, there's really valuable material coming out of it. The same thing here, the purple and the red are clays. And so that's also part of our resources that we use. So this is a construction site in High Brussels. We excavate, or at least the earth worker is excavating sand there, and we reuse this type of sand in our products. This is an excavation site where we use clay from. This is in Low Brussels, and they touch on a very, very valuable, very strong clay layer with super strong cohesion. So very, very good for certain applications in earth construction. And for coarse sand and gravels, we use, in fact, recycled debris. So it comes from crushing concrete, crushing nature stone, crushing baked bricks. These are our gravels that we use, for example, in our rammed earth. So this is our production place, 1,000 square meters in the center of Brussels, really in the heart of Brussels. And this, it's just a production hall, there's no inside space, there's just containers and these Lego blocks with a wooden roof on top. Under the roof, we dry. Outside of the roof to the left, we have a big drying, under the roof, sorry, we produce. And then on the left of the roof, behind the containers, we have a big drying surface. So we sun dry our materials before, our resources, before turning them into materials. And here we see, for example, a block production going on. This production hall of BC Materials, it's not only a place for production, it's also a place for education. And we organize a lot of workshops for architects, contractors, students, clients, do-it-yourselfers, and so on, in order to be introduced to earth as a building material, because in the Benelux, we did not get as far yet as the Germany or France, for example, in terms of earth construction. So we need a lot of sensibilization. And then BC Materials sells these three materials. We have the compressed air block, which is called briquette. We have the clay plaster, which is called brusselaire. And we have the castar, which we have the rammed earth, which is called castar. So three products that we're selling. Here we see some textures of the product. It should actually be like inverse, but that you will have seen already. And this is the packaging that we have. In the meantime, the packaging changed a little bit, but the idea is really to bring this onto the market as stock products, and besides our project-based projects. So these stock products that we're selling, that's for people who just come and get the materials. We have other kinds of projects where people want more involvement from us as consultants. For example, this is a project by de Gouden Lineaal Architecten, where BC Materials, together with Crater, was the consultants in how to use earth from the side or from the immediate environment to make it into rammed earth. So this is a 12-meter high exposed rammed earth watchtower on top of a landfill. So that's kind of funny. This is a landfill of an old quarry that was filled and now became a natural park. So, it's like a full cycle that we use earth from that landfill to make the rammed earth watchtower there. Here, a very beautiful project by Este 77 architects, where BC Materials, together with the contractor Liniscat, did the 15-meter high rammed earth wall. To our knowing, it might be the highest unstabilized rammed earth wall in the world. And so it's made from earth from the excavation of this basement, mixed with gravels and sands until we have this rammed earth wall into his project. A project by BC Architects and Studies where we renovated a barn into a contemporary bakery. So it's an old barn from the 17th century that was renovated with local and natural materials. We have here comptoir, like a kind of counter in rammed earth with wall heating inside. So this was the heating element for the space, and then with earth plaster, and then here hempcrete boxes for like the fridge and so on. And yeah, just to show that BC Materials really wants to help other architects, clients to build with this abundant resource that we excavate anyways in our economy and that we consider legally as a waste. We say, hey, it's not a waste. Let's do something with it. And that's also in the mission of our BC Materials cooperative. It's a cooperative. The aim is not necessarily directly profit. The aim is written in the mission to really kickstart the transition in our construction sector and to grow the earth building materials markets in Belgium and also the Benelux. So I think that's it. Maybe already some topics for discussion. I hope it was a bit clear that we considered architecture not to be just to design plans and to give it to a contractor and to control that contractor, but it goes really much more into education, building together, producing materials, and so on. And we really believe that this wide approach to architecture is needed in order to bring about change. So yeah, maybe a topic for discussion. You can find us. Here are our websites if you want to see a bit more information, or our Facebook or the Instagram you'll find with Google also, no problem. So I would say let's keep in touch and let's discuss some questions that you might have.
Thank you very much, Ken. I think it was super clear and super interesting. And indeed, for sure, I think that in order to trigger a real impact, it cannot just stay in the building sector, and it needs to go to education and to teaching. And I'm also really interested of knowing how students, accept, or how students are interested on this kind of projects, which are, I'm sure, really different from what they are teach when they are studying. But let's go to the questions first, and then we can see if I can also solve some of my questions. So we have some questions about the beginning with the Mujinga project. The first one, did the perception of the community change it from the Adobe bricks to the CB? In other words, did people accept it much more the CB?
Mm-hmm. Indeed, I have to even say the project was a no-go if it was with the Adobes. So there was a big difference in this more strict lines of the compressed air blocks. While we tested both blocks back in the days, in terms of compression force, there was not a lot of difference, or maybe no difference between the two technologies. But it really made a difference, just the cultural difference, I would say, to have this production process of the machine, to just have the machine doing its thing. it uplifted the value of earth as a material, because just like in Belgium, just like in Burundi, earth on itself did not have a lot of value, let's say. So it's only normally when you do something with the earth, let's say, when you process it, that it has value. While we know that it shouldn't be processed so much, but still the act of processing it was more a cultural act, let's say, in order to get the CEBs accepted. And so in the end, there was a lot of skepticism also about the CEB in the beginning. We could start with the CEB, but there was a lot of skepticism. And then when the building was finished, the skepticism changed already more into pride, with a little bit of insecurity. And now over time, they're happy with the building, and they really trust the material. But yeah, it took time, of course.
Indeed, I think that innovation in this sense changed also the perception of people towards the use of some building materials, right?
Indeed.
Yeah, really interesting. So there's another question about the library. So how did the community participate in the design construction of the Muyinga project? What kind of activities did you do?
Mm-hmm. So I would say the participation of the community in the design was maybe a little bit less, because we were working with this local partner who organizes the education, and so they had a school for deaf children somewhere else. They were kind of experts in how to run infrastructure for deaf children. And so it was mainly with this local partner, with the people of the local partner, that we were designing. And then in terms of technology, in terms of construction, it was totally Salvatore. So I would say we didn't design with everyone of the community. We designed with some people of the community. Where the participation with everyone of the community was more like the soft participation, like with all the people who worked on the project, sometimes 60 people. We would slaughter a goat and do a barbecue, and it's just how things are celebrated there. So it was more like the soft contact, soft participation. Invite them to the place where we were staying in Muyinga. And of course you talk about the project, but it's in a different way than sitting around plans and discussing plans or something. So it depends which group of people, which kind of participation there is, I guess.
Mm-hmm. Yeah, I imagine that also having a local constructor that was already organizing and sensibilizing community was, I think, is already something really important in a way of promoting the project. Well, so now we go to the questions of how did you move to Brussels? That I think is the big challenge, the bigger challenge you have faced. And actually, I was thinking while I was hearing to you, it's thrilling to hear how from being students trying to build something with earth without no previous knowledge, then everything moved to what you are doing now. And I think it's really emotional. And so I'm sure that's why many questions about these periods. And there's Jorge asking, how does the building regulations in Belgium affect the use of CEB?
Yeah, so indeed, maybe to frame a little bit also this transition from the work that we did in some African countries to then working in Belgium. It was we really came into a context where there's nothing happening in terms of, and in the meantime a little bit, but back in the days, nothing happening in terms of earth, in terms of bio-based like hempcrete and so on. And so that was also an opportunity, I think, because Belgium is a very small country. It's not as organized as France and Germany in terms of the construction sector. So there was a lot of gray zones. Just to give an example, we called to our insurance company and said, hey, can you adapt our contract to include also work with straw, earth, hemp, and flax, and so on? And so just a call, no problem, and they send the contract, and so we got insured just like that. But in France or in Germany, what you need to do to be insured in order to work with these materials, it is just crazy. It's like you have to do testing of 100,000 euros for certain per material that you use and so on. So it's like, it's a different world. So that was an opportunity for us. The fact that things were not yet organized in Belgium, it was really, really an opportunity. So we kind of put our foot through the door with this Edegem project. It was a public project. We made an offer without talking about earth or hempcrete. We made a small sketch design. They chose us from this group of people. And then from the moment they chose us, we said, yeah, but come on, you're an external classroom in ecological education. We should really do an exemplary building. And then the process started. And we really, as I said before, we really had to design the process of having these materials accepted, which meant prototyping workshops together with the client and stuff like that. To answer more specifically on the question, so how does the building regulations Belgium affect the use of compressed air blocks? In fact, there are no building regulations. And in fact, the insurance companies are very, very flexible because they don't really know what it's all about. So when you make your own protocol and you have it accepted by the stability engineer, the guy that you saw masoning with the blocks in order to convince him, then you can do it. So that was a lucky thing to be in Belgium for that. If it was in France, it would not have been possible.
So then we could say that being pioneers on something, it had disadvantages, but as well advantages, no? So you could start moving forward. Really interesting. So there's also another question, I think, in relation to bureaucracy. So there has been any changes in administration and policies to develop alternative ways of constructing after your works?
Mm-hmm. There has a lot of things are moving. For example, now the Belgian Federation for Construction and Norms is in fact has started a research group around translating the German norms for earth construction for the Belgian context. So of course that has to do with what we did, but also what some contractors in Belgium were doing with earth. So it's like this small network that starts to grow. And so yeah, these projects, they have been really published a lot in Belgium, also outside, but also a lot in Belgium. And people really know these projects, like that's the house with the compressed air blocks or the hempcrete, and yeah, like people start to work on it. There has been the research of the UHasselt on hempcrete, for example. Now they made a publication, a very complete publication about how to implement hempcrete in construction. So more and more things are happening. It's of course not only because of our project. It's just a whole shift. Yeah, that as a society, as a sector, that we start to realize like, whoa, we cannot totally rely on industrial materials anymore. And we're a little bit surfing on the wave of that shift and showing these first exemplary projects. But it's not us. It's actually the wave. You know, it's the necessity within our society.
In fact, I hope this is the move that is going to happen later or before in the whole Europe and in the whole world at some point. And for sure, we are already seeing some of these changes in many places, which is a good news, let's say. So another question, which challenges do you have implementing these building materials in this context? So yeah, here we could say, which are the biggest challenges you are facing?
Yeah, it depends a little bit on what type of material. Sometimes it's the cost. For example, compressed air blocks are, it's just impossible to compete with a concrete hollow block. So in terms of cost price, even though masoning is the same, if you mason a compressed air block or a concrete hollow block, it's the same. Maybe you have to know a little bit that you cannot tap as hard with the hammer to put it in place, but for the rest, it's really the same. So there, it's more the cost. For rammed earth, for example, it's really the workmanship. Rammed earth is expensive, but it speaks to a different market, so people want to pay for it. It's just that you have to find contractors who can execute it. So there's the workmanship is important. For clay plaster, there are other things. So yeah, I think different challenges for different materials. I would say cost and workmanship might be the biggest challenges at this moment. Yeah.
Okay, good. So we move now to the last of the questions. How do you think it is possible to trigger a bigger impact at a higher scale from the current construction models? Good one.
Yeah. So we've been also asking us this question a long time ago, and we are trying to answer it by our activities that we're doing. So one way for us to trigger a bigger impact was to start a material production company and to offer other contractors and clients and architects to also build with these materials, because before there were just projects of BC architects. So that is the first step. A second step is we now want to really implement exemplary projects in a bigger scale, but it takes a long time. These are often public tender processes. For example, we are already speaking for some projects that will have high quantities of compressed air blocks and clay plaster. We're already speaking with them for 1 year and a half, 2 years. And now 2021 will be finally the production and implementation of these building materials. So these are projects of 10,000 meters square, 20,000 meters square. So much bigger projects. And we think that when you just show that you have done it in this scale of project also, that suddenly all those players on a different scale in the construction sector will maybe start considering these kind of materials also. Because, for example, you have to imagine project developers, contractors, and so on. They need to more and more respond to exigence in terms of ecological accounting. For example, there's like the financial budget which is being made, but there's also the ecological budget, CO2 equivalents, which are being made more and more. In Germany, it's already all over the place. In Belgium, it will come. They're implementing it now. So you have to imagine that also those big scale projects will need answers in order how to construct low carbon. And so one of these answers, of course, is earth. Other answers are building with fibers, like using wood, using hemp, using flax, and so on. And so it's true that we do our best as a small organization which is growing. We're now with 20 people. We do our best from our side to be able to work on a bigger scale, but there also needs to be from the other side, the policy and so on. There also needs to be the incentive that these big scale projects will happen. Just to give you an example, the cement sector is still being subsidized for around 5 to 6 billions over 4 years, billion euros. These are huge amounts that the bio-based sector is not receiving. So, if we want an impact on a big scale, it's also there that we need to change things, it's also in the way, for example, how we count carbon. Like the steel industries, they are having their waste, and they send their waste to the cement industry, and they say, we don't count our carbon because our waste is being reused by the cement industry. And the cement industry, they're saying, we're using waste as an income, so we're not counting that carbon. So we end up with the carbon nowhere being counted. So that's the situation today in Europe, how you can say that you have a low carbon concrete, for example. It's just bullocks. But we need to change the regulations so that this cannot happen anymore. And all of these changes on this level totally above us will also need to happen in order to make bigger scale projects possible for bio-based and geo-based construction.
So do you think that all these actors involved in the construction sector that are not the architects as constructors and the ones who promote the big companies of materials are already willing to be part of this change, or they're still, let's say, reticent to the change that needs to happen?
Yeah, they're a bit resistant, but they need to change. They don't have a choice, and they feel it. They feel the heat, and the heat is really coming. They know that the carbon, that the carbon accounting is just a matter of a year or maybe 2 years in Belgium. They see it in Germany happening. These are international companies. They see it happening everywhere. Now in France with the Plan de Relance, they're going to invest so much in the bio-based economy. Like all the companies are feeling it, that there's a shift happening. It's just that the shift takes a few years. But we feel more and more companies also coming to us, bigger scale companies who are searching for ways to find answers to this shift, and who consider us as one of the possible answers. And so we try to convince them that, yeah, we are one of the answers. That's what we're doing right now at this moment.
I'm sure that even only with the facts, you don't need to explain so much what you do to convince, because in the end, is as you say, the movement that we need in our society right now. So
Indeed.
for sure. I'm just saying there's another question, maybe it's a bit outside already the conversation, but I'm taking a look to it, and it says, how do BC Materials compressed earth bricks differ from the bricks produced by TerraBlock, CH?
Yeah. So TerraBlock is an organization in Geneva. They're very, very cool people doing really nice things. You should really check them out. And so, in fact, BC Materials is not operating alone in Europe. We're totally in connection with all these other companies who are starting up. You have Cycleterre in Paris also. And so, in fact, TerraBlock, Cycleterre, and BC Materials are at this moment the companies which are reusing excavated earth to make earth building materials. So we are in contact. We are meeting to exchange. We're trying to see how we can substantialize our network even more. So we're very similar. How our compressed air blocks would differ from the ones produced by TerraBlock, I think mainly it's the way of producing at this moment. They produce mostly in cooperation with a concrete block producer. So they put earth in a concrete production chain, concrete block production chain, while we at the moment we are using specific compressed air block machines. But the type of stone that come out is quite similar in terms of characteristics and so on. So not so much difference.
Thank you for the answer. It seems that people is getting more active right now. We have another question.
Okay.
It says, how to prevent cement manufacturers or industries from imposing poured earth techniques?
That's an interesting question also. We feel sometimes that there is an interest of concrete sectors in what we're doing. So it's not even only about it's not even only about poured earth, but it's also even about other earth techniques that they're kind of interested in seeing how, what can be done there and so on. I don't know if it's our job to prevent the cement manufacturers to go into earth. Maybe it's a good sign if they go into earth. I don't know. What we just need to make sure of with these small actors is that we keep true to our mission, which is shifting the construction sector, offering real alternatives to the building materials market and so on, in terms of low carbon and health and way of operating. And we are a cooperative, a workers' cooperative. So our workers are part of the company. So it's a bigger concept that the cement industries will never have. I don't say that we can reach all of the population. So maybe there's a place for cement manufacturers or industries to go into earth. but maybe we should be so strong in what we do that they will maybe not find a market to have this kind of cement stabilized poured earth, which is actually a concrete where you replace the sand with earth, but it's can be most of the time there's a lot of cement inside. So I think we need to show the different way and believe in the strength of what we're doing, that there will always be people who choose to support what we're doing instead of what the big cement industries might or will be doing. It's like going to the, I don't know, yeah, it's maybe a bit of a weird example, but it's like going to the bio shop instead of like a supermarket that has weird business models in other countries that brings chicken from from super far away and so on. Maybe it's this kind of consideration that people will make. Let's see, we don't know.
Thank you. Actually, you were reminding me something that Mariana said yesterday that is really similar, and is how sometimes we expect that are the politicians or those who control, who can make this change, but actually is on the community, on the people where the change has to come, and from where we have to move, to teach and to enlarge the knowledge, so everyone will have the possibility of accessing this kind of materials, which are where we need to move, and also that needs to be available also for everyone. So to make this change in a responsible way, let's say. So I think it has been super interesting hearing you, and all the work you are doing is super inspiring. And I have seen there's people saying thank you from different places, so different parts of the world. So I hope this speech was useful and as well inspiring for many of you who want to change the construction sector, the architecture, and the way we see the world from many different places. So to make this change all together. So I think that's it. I really want again to say thank you to you for your time, for being here with us, and for showing us the beautiful work you do. Keep please doing, updating and rocking with the work you do, because we think that this is the move we have to make, all of us, and it's an effort, but as well is a good place where to arrive, let's say.
Mm-hmm. Yeah, thank you everyone for your attention. Would love to keep in touch, maybe digital or something. I would love to meet you in person also, because online is nice, in person is nicer. But let's be in touch. Thank you for the invitation. It was really interesting also to receive the questions. Thank you very much, everyone.
Thank you to you. So see you soon.
Yeah, bye-bye.
Bye-bye. Thank you to everyone, and be here tomorrow at the same time for the last conference series. Bye-bye.